So before we learn how to solve problems about inverse functions, we need to talk about what an inverse function is. We know that a regular function applies some sort of rule to an input. So we put in the input x, it goes into the function f of x, and then it spits out an output, y. For example, the function f of x equals 3x plus 1. If I put in the number 2 as my input, and I put it into this function machine, I would have to do 3 times 2 to plug in for x plus 1. So that's 6 plus 1. I would get out the output 7. So if 2 is my x value, 7 is my y value. What an inverse function does is it reverses the rules of the original function so that when you put in the outputs from before, you get the inputs from the original function. So inputs and outputs switch. So if I put in 7 into my inverse function, I should get out 2, which was the input from before. The notation for an inverse function looks like this. It kind of looks like it has a power of -1 up here, but it has nothing to do with exponents. It's just a symbol that means inverse. So we read this f inverse of x. So if we're looking at the tables of f of x and f inverse of x, we should notice that all of the x values and y values switch. So we already plugged in 2 into f of x and we got 7. I'm going to try plugging in 3. So that would be 3 times 3 plus 1, so that's 9 plus 1, which is 10. And I'm going to plug in 4. Times 4 plus 1 is 12 plus 1, which is 13. So here's my little table of f of x. I just plugged in 3 x values. Now I'm going to show you soon how to find the actual function for f inverse of x, but just to show you what should happen, my function from before had x values 2, 3, 4. 2 gave us the output of 7, 3 gave us the output of 10, 4 gave us the output of 13. What should happen in my f inverse table is that my x's and y's switch because inputs and outputs switch. So if I put in 7, I should get out 2. If I put in 10, I should get out 3. And if I put in 13, I should get out 4. So when we look at the two tables, we can see that the x value and y value columns switch. So let's go through some examples you'll see in IXL. Well, on Tuesday, we're going to be actually finding that inverse function, and in order to do that, we need to remember some of our algebra skills for equations and also how to reduce fractions if we need to. So on Monday, you're going to be practicing just reducing fractions, so writing a fraction in lowest terms. In order to do that, remember that we want to divide the highest number that we can from both the top and bottom of the fraction. So I need to think of the highest number that goes into both 6 and 9. The best thing to do is to start actually with the smaller number of the two that I see. So the smaller number I see here is 6. Can I divide both of these by 6? I know I can do 6 divided by 6, that's 1. But I can't do 9 divided by 6 and get a whole number. So 6 is not going to work. I'm going to keep going down because there's not that many numbers. So next would be 5. Can I divide both of these by 5? No. Can I divide both of these by 4? No, 6 divided by 4 gives me a decimal. Can I divide both of these by 3? I can divide both of these by 3. And they will both give me a whole number. 6 divided by 3 is 2, 9 divided by 3 is 3. So 2/3 is my reduced fraction. On Tuesday, your problems will look like this. Find the inverse of the function. Well, sometimes you'll be given a function that says f of x at the beginning. Remember that that's just the same as y. So if it does say this, just first change f of x to y as your first step. If it already says y equals, then you can go on to step 2, which is switch x and y. Remember that the whole point of inverses is that the inputs and outputs switch. So I'm going to rewrite this as x equals y minus 8. Now technically I'm done. This equation represents the inverse of y equals x minus 8. But we always want our answer to start with y equals when we're writing an equation. Notice they prompt us here with y equals. So in order to get y alone, I need to undo the operations that are happening to y so that y is by itself. Well, next to the y, I see a minus 8, so I'm going to add 8 to both sides to get rid of that. So now I just have y on the right, and I have x plus 8 on the left. So I've now isolated y. I just want to put it on the left side, so I'm going to switch the order of this equation, so it's y equals, and then x plus 8. And that's my inverse equation. So I can put in x plus 8, and I'm done. Let's do another example. So if my original equation is y equals negative 3x, I'm going to switch x and y so that it says x equals negative 3y, and then I want to isolate y and get it alone on the left. So right now what's happening to y is it's being multiplied by a negative 3. So I'm going to divide negative 3 on both sides. Now I have y alone on the right, and I have x over negative 3. In order to get y on the left, I'm just going to swap the order of my equation. So everything on the right goes on the left, and everything on the left goes on the right. So x over negative 3 is my answer. In order to type that, I'm going to click this button. It will give me a little fraction setup, and on the top I'll put x, on the bottom I'll put negative 3. Okay, my last example is probably the one that you'll see with the most steps. I'm first going to switch my x and y, so I'll write this as x equals negative 2y plus 7. I'm going to circle y and get that alone. I have to think about what I need to do first. Remember, if I have multiplication and addition happening to y, I want to get rid of addition first. I want to get rid of that extra constant at the end. So I'm going to subtract 7 from both sides to get rid of that constant. On the left I'll have x minus 7. On the right I'll have negative 2y. I still have one more step to get y alone. It's being multiplied by negative 2. So I'm going to divide by negative 2 on both sides. So I have y on the right and x minus 7 over negative 2 on the left. But the directions say to write your answer in the form ax plus b and simplify any fractions. So what I need to do is divide both of these terms, the x and the minus 7, by negative 2 so that my terms are separated out. So I'm going to first switch my sides so it says y equals x minus 7 over negative 2, and then I'm going to divide each term by negative 2. So I'd have x over negative 2 and then minus 7 over negative 2. Now I still have a little more work to do so that it says y equals something x plus something. I want to figure out what that fraction is that's going to be in front of x. In front of x down here is a little hidden 1. So 1 over negative 2 would be my fraction. Remember, I want my negative to be on the top if there's only one negative. So I'm going to write it as negative 1 over 2. And then my second number, it's really like a -7 over -2. I have two negatives here being divided, and that means it's going to become positive. So this will be +7 over 2. Finally, I'm going to think about if I can reduce any fraction further. So that 7/2, is there something I can divide both 7 and 2 by to reduce this? In this case, I can't. So I'm going to leave 7/2 as it is. Remember, when you're entering your answer, every time you do a fraction, you need to use this button. As you saw before, the table for an inverse function just switches all the x and y values. So it tells us the function f of x is invertible. We can find the inverse. Find f inverse of 35. Well, we know the table of f inverse of x is going to look like all of the x values being on the y side and all of the y values being on the x side. So I can quickly make a table for f inverse of x by just copying those columns. So now that I have my table for f inverse of x, I can find f inverse of 35. I'm going to find where the x value is 35, which is here, and find its output, which is 34. Now you might have noticed on the original table, when 35 was the output, 34 was the input. So as you do more of these, you might not need to make an entire table for f inverse of x. You might find that this is just asking you for 35 as the output of the original f of x, and that it wants the input. Another quick example is if it asks for f inverse of 45, I could just look up here where the output of f of x is 45 and find its input, 44, because I know when I do the table that it will just be in reverse order. Okay, same idea for a graph. Inputs and outputs switch. On my inverse table, if they're asking for when 2 is my x, that's going to pair with the same value when on my regular f of x table, 2 is my output, my y, right? Those are going to be the same value in that position that I circled. So since we have the graph of f of x, well, I'm looking for when the y value is 2 on the regular f of x graph. So here's where y is 2, all of these points, and it looks like this is the point on f of x where y is 2, and that pairs to an input of 6. So that means on my f inverse table, when 2 is the input, 6 will be the output. So f inverse of 2 is 6.